All right, 5.3 medians and altitudes of a triangle. So median is a new vocabulary word as far as the triangles go. The altitudes, hopefully you remember. But the median of a triangle is where you connect a midpoint to the opposite vertex. All right, so midpoint means this segment is the same length as that segment, and we connect it to the opposite vertex. Notice the median is always in the inside of the triangle. And the next thing is an altitude. The altitude is the height of the triangle. In this case, the altitude's inside the triangle. Sometimes the altitude is outside the triangle. When you measure the height of something, you always measure perpendicular to the ground, right? Point, the height of this point, perpendicular to that line there. So we had to extend out the base. So our next theorem, basically, I'll read it first this time. The concurrency of the medians of a triangle, concurrency means they all intersect, three lines that intersect at one spot. And there's an interesting thing that happens. This segment is divided into some parts. Okay, basically, this length PD is the length 1/3 of the total length. AP is 2/3 of the total length. And then so basically, if this is 1/3 and this is 2/3, how does 1/3 relate to 2/3? Well, half of 2/3 is 1/3. So half of AP is the length PD. Okay, so now I'm going to look at this in GeoGebra, and you see they have segment CF here is a measure of 2.29. BC has a length of 4.59. So 2.29 is basically 2.3, 4.59 is basically 4.6. So there's a little bit off with the rounding, but as I move the segment around, is this length still half of that length? About 7.6, 3.8. You double 3.8, you'd get 7.6. And if I move this point, it still is the same. And notice it's not just for this segment, but they're all that way. Okay, so that is the medians. Notice the medians of a triangle are always on the inside, that point of concurrency. And we call that point of concurrency the centroid. The centroid is the balancing point of the triangle. And in this case, the centroid of this bird is that balancing point. Okay, I have one of those in my class, in my desk. If you guys want to see it, just ask me. I can show you that. It's kind of a fun toy. Now, we're going to use that theorem about how these segments relate to each other to find different pieces. So we're given that PT is 5. So if this is a homework problem, I'm going to redraw it in my paper and label the given information. I want to find RT. RT is the whole length, and RP. So how does PT relate to RP? Remember, this is 1/3 the whole, this is 2/3 the whole, so RP is twice PT. So if I double 5, this segment has to be 10. So 2/3, 1/3, together 3/3 is going to be 15. So RT equal 10, and that was 15. And RP equal 10. Okay, so 1/3 of 15 is 5, 2/3 of 15 is 10. And if you remember how to multiply fractions, I multiply by 2/3, my 15's reduce. That'd be 5 over 1. 3 goes into 15 5 times. So you get 10. say 1/3 of 15 is like divided by 3, you get 5. This next example about the centroid, there's different ways you could do this. You could actually find the midpoint of this segment and visually seeing I go up 2 over 2, up 2 over 2. This has to be my midpoint. And I could find the midpoint of this segment and the midpoint of this segment and connect them to the opposite vertices to try to find the centroid. So what is that point? There's another way you can do it. This is how the book shows it, but I've heard students tell me on the MCA test they actually find a centroid of a non-triangle, the balancing point. They're supposed to do that on one of the questions, and so I'm going to show you this method because this is what the question asks you to do. But they just say find the average of your x coordinates and the average of your y coordinates. So labeling these coordinates, B is 2, 3, E is 3, 6, 7, 8, X is 8, Y is 1, 2, 3, 4, 5, and F is 4, 1. So the coordinates of your centroid are going to be the average of your x coordinates. So 2 plus 4 plus 8 divided by 3. There's 3 coordinates. So if this was a quadrilateral, we'd have to have 4 numbers divided by 4. Right? That's how we find averages. That's my x coordinate. My y coordinate is 3 plus 1 plus 5 divided by 3. And this will quickly find that centroid, which will be, so 6 plus 8, 14 divided by 3. And this one is 4 plus 5, 9 divided by 3. Well, 9 divided by 3 is 3. And 14 divided by 3, 3 goes into 14 almost 5 times. 4 times with a remainder of 2. Does that point make sense? Over 4 2/3 and up 3. Bingo. That's my answer. I kind of, this is pretty quick too. It'll save you some time. Highly recommend it. Okay, now you could sketch this out and see where they hit too, but now the orthocenter, this theorem is not nearly as exciting as the other ones. I know you don't think those ones are exciting, but this one, basically, the only thing in the theorem is that the altitudes are concurrent. So the altitudes are all going to intersect in the same place. And anyways, so I got point C in here, and the orthocenter is labeled, but how you find the orthocenter is you need to draw in 3 altitudes. Right now I have 1 altitude. Remember, it's perpendicular to the base. The base does not always have to be on the bottom. Notice sometimes the altitude is on the outside. And I'm going to click this button here, and it's going to show me all 3. Now it's not working. Hold on. I wonder if it'll like me better now. Okay. Alright, so for some reason it wasn't working way over there. But now you can see that base does not necessarily have to be on the bottom. It can be this side. So if this is my base, and then notice I have to extend the line because sometimes that altitude is outside. So if I move point A this way, after a while this altitude is going to be on the outside. And notice sometimes the orthocenter is on the inside. When we get an obtuse triangle, it's on the outside. And on a right triangle, the orthocenter there, all 3 altitudes intersect exactly at that vertice. Okay, so there's your altitude. That's about the only interesting thing that's going on there. Nothing about segments being congruent or anything like that. Alright, so back to the notes. There's your homework assignment. Ignore the quiz thing. I forgot to take that off. You guys know that you have should take the 5.3 quiz after you watch this. Good luck, and see you in class.